Welcome back for another deep dive. Today we're taking a look at a paper that really shook things up in astronomy. Edwin Hubble's 1929 paper that showed us the universe is expanding.
Yeah, this paper was a pretty big deal for our understanding of, well, everything out there.
It really was. And we're going to break down how Hubble got to this pretty wild conclusion and what it means for us today, almost a century later. But before we get into all that, I think it helps to understand what astronomers thought was going on back then.
Right, before Hubble came along, everyone pretty much thought the universe was this, this unchanging static thing. Like it was just our Milky Way galaxy just hanging out there all by itself, not going anywhere.
Yeah, a little less going on than we know of now, right?
You could say that again. And get this, even back then, astronomers were finding this weird thing they called the K term. Like they'd be looking at these distant galaxies, and it was like they were moving relative to us here on Earth. But the way it all moved didn't really make sense.
So this K term sounds important, like it was something Hubble was trying to figure out.
It was a big deal, yeah.
Hmm.
Okay, so think of it this way. You're carefully tracking how stars and galaxies are moving, right?
Mm-hmm.
You're working with this idea that the universe is mostly this still, unchanging thing, but then your calculations keep showing this weird extra movement, this K term, that you just can't explain. Like it's not the Earth rotating or the sun moving around in the Milky Way.
It's like you think you have this jigsaw puzzle all figured out, and then you find this extra piece that doesn't go anywhere.
Exactly. And this extra piece, this K term, was messing with the whole picture. It was like it was hinting that something was off with, like the entire way we understood the universe.
Makes you wonder if some astronomers at the time just kind of hoped it would go away if they ignored it.
Oh, I'm sure some did. But thankfully some, like Hubble, they realized this wasn't just some random thing. It was a sign that maybe, just maybe, the universe wasn't as static and unchanging as everyone thought.
And that's where Hubble's work comes in. He was determined to get to the bottom of all this. But how do you even begin to measure something as mind-bogglingly enormous as the universe, especially with the technology they had back then?
Well, Hubble focused on two really important things to figure this out. Distance, how far away things were, and velocity, how fast they were moving. And to measure those huge distances to other galaxies, he used these really cool stars called Cepheid variables.
Cepheid variables, aren't those the ones that, like, pulsate?
Yeah, they
Like cosmic lighthouses that kind of, I don't know, blink? And you can use that to, like, measure how far away they are?
That's a really good way to think about it. It's like
Yeah.
they have this pattern, right? And the brighter ones, they pulsate slower. And the dimmer ones, they're faster. So Hubble, he timed how these Cepheid stars pulsated. And that let him figure out how bright they actually were, like how much light they were actually putting out.
So he had, like, a cosmic measuring stick. He could compare how bright they actually were to how bright they looked from Earth. And that told him how far away they must be. Pretty smart, right? But knowing how far away all these galaxies were, that was only part of the puzzle, right? He still needed to know if they were moving and how fast.
Exactly. And that's where the second thing comes in, redshift. So Hubble's looking at the light from these galaxies, right?
Yeah.
And he's finding that the light waves are like stretched out, shifted towards the red end of the spectrum.
Redshift, right. And that's stretching. That's how we know the galaxies are moving away from us. But how do you go from, like, moving away to knowing how fast?
So that's the cool thing about redshift. It's not just, is it moving, yes or no?
Yeah.
It actually tells you how fast. The more redshift, the faster it's moving away. It's kind of like, when an ambulance passes by and the siren changes pitch.
The Doppler effect.
Yeah, exactly. The Doppler effect, but with light. So just like the siren seems lower as the ambulance moves away, the light from a galaxy, it stretches towards the red end of the spectrum as it moves away from us.
So more redshift, faster it's moving away. It's like the universe is talking to us. Wild. And Hubble figured all this out with what they had back then. I mean, seriously, it's amazing.
It's incredible. Years of work, collecting data, carefully looking at the redshift of all these galaxies, figuring out their distances. He was really meticulous about it all. And it led to a pretty huge discovery.
So what was the big discovery? What happened when he put it all together?
He saw this pattern. He realized that the farther away a galaxy was, the faster it was moving away from us. It wasn't random or anything. There was this clear connection between distance and velocity. And he even put it all into a table in his paper. He had data for 24 galaxies, their distances, and how fast they were moving.
So it wasn't just that the universe wasn't static. It was that everything was moving apart in this, like, organized way. Like, imagine drawing dots on a balloon and blowing it up.
Yeah, like that. That's a great way to picture it. What Hubble was seeing, it meant that space itself was expanding, and it was taking the galaxies along with it. which was this huge idea. It completely changed how we thought about the universe. And this is more to the paper, too. He actually took his discovery and used it in a whole different way, too.
Okay, so he figures out the expanding universe, just drops that bombshell, and then there's even more in the paper. What else did he find?
Well, he had this table in his paper. It had 22 galaxies, but we didn't have good measurements for how far away they were yet. But he realized that he could actually use his discovery, that connection between distance and how fast a galaxy's moving. He used that to figure out how far away those other galaxies were.
Oh, wow. So he took this brand new idea, this expanding universe idea, and used it as like a tool to discover even more about the universe. That's pretty cool. How did that even work?
So remember how he found that really clear pattern? The farther away a galaxy is, the faster it looks like it's moving away. He basically just used that backwards. He took how fast those 22 galaxies were moving, plugged it into his formula, and boom. He had a way to estimate how far away they were.
So it's like, okay, if the universe is expanding at this speed and this galaxy looks like it's going this fast, then it must be roughly this far away. Wow.
Exactly. And it gets even better. He took those distances he just figured out, and he used them to calculate how bright those 22 galaxies should actually be. And guess what? Those calculations, they matched up with what we'd expect for galaxies like that.
So he looked at this whole other group of galaxies in a completely different way, and it backed up his original findings. Like the universe was saying, see, told ya.
It really does make you think about what Hubble could have done with today's technology, doesn't it? What he did, it completely changed how we think about space.
It's amazing. This one paper just blew up the whole idea of a universe that just sits there. Hubble showed us that it's huge, it's active, things are always moving.
And probably the biggest thing is that his work, it led to the Big Bang Theory. That idea that the universe had a beginning, a starting point. Hubble's expanding universe, it was the evidence to support that.
It's incredible to think that one scientist and a telescope, they could discover something so important about everything.
It really makes you wonder, if the universe is always expanding like this, what happens eventually? Are there things out there in space that we haven't even imagined yet?
I guess those are questions for another deep dive. Thanks for listening today while we explored this incredible discovery by Edwin Hubble. And until next time, keep looking up.